It is my pleasure to introduce Tim Frazier. Tim is my neighbor. He is also a telescope maker and past president of the Magic Valley Astronomical Society. He has an undergraduate degree in mechanical engineering from Vanderbilt University and has published papers on eclipsing binary stars. He was the faculty sponsor for a NASA-funded high-altitude balloon project for 6 years, which launched experiments and cameras to altitudes in excess of 90,000 feet. In 2009, Tim headed a team of colleagues from Idaho State University that built an experimental capsule which was launched into space by NASA. Not only does he have a scientific bent, but he also has an artistic bent. He received his MFA from the University of Florida and has worked in over a dozen international collections, including the Art Institute of Chicago and the Museum of Modern Art in New York City. And last but not least, I think this is pretty exciting, the Haley Public Library was contacted on Monday by the producer of the CBS Sunday Morning Show, who asked if I could put him in touch with Tim. So CBS Morning Show is doing an interview with Tim in the upcoming weeks because they're featuring the Central Idaho Dark Sky Reserve and the Perseid Meteor Shower. They're going to be here in the valley apparently. So, so I have you all on, let's see, I have you all on, let's see. So I am going to spotlight Tim and we'll be ready to go. Great, Tim, you're on.
Okay, great. Thank you. And thanks everybody for coming. I want to start by thanking the Haley Public Library.
I have one thing I have to interrupt and say. I forgot to mention it. If you have any questions that come up, please put them in the chat. I'll be monitoring the chat, and when there's a kind of a little break, I'll interrupt him, and so we'll ask questions as we go along. So the chat is in the bottom middle of the screen, and you just click on it, a little window comes up, and you'll type your question into the bottom. So sorry, Tim, I just realized I hadn't mentioned that. So.
Oh, that's fine. That's fine. I was just saying that I really appreciate the efforts of the Haley Public Library to bring all of this, all of the talks and things via Zoom to the community. It's a really important resource, and I hope everybody supports it. And thank Kristen for all of her efforts in setting this up. There's a lot that goes on behind the screen to make all of this function. Okay, I'm going to start my presentation here. Well, to begin with, it's interesting to me that when it comes to weather, you never really know what's going to happen when. Meteorologists tend to know, well, something's coming, and it's just the timing of it. Astronomers don't have that problem. Our showers are very predictable, okay? And the one that we're going to see next week, whoa, what am I doing here? Is, there we go, the Perseid Meteor Shower. Now, this particular image is several exposures together to make this wonderful grouping of meteors, and you can see Mount Rainier in the background. The thing about meteor showers is they are certainly quite beautiful, and these meteors streak in from outer space. And of course, the question is, where do these things come from? Well, I'd like to begin by talking a little bit about nomenclature. When it's in space, a piece of rock is called a meteoroid. When it's in the atmosphere, it's a meteor. If it hits the ground, it's a meteorite. So a roid, a meteoroid, a meteor, and a meteorite. But where do these things come from? I mean, what causes them to hit the atmosphere at extremely high speed and burn up? The source of meteors are comets. What happens is, as a comet sweeps by the Earth, and this is Comet Swift-Tuttle. This is a photograph made by E. Barnard in 1892. This particular comet, named after the two people who discovered it, is the source of the material that creates the Perseid Meteor Shower. As comets get close to the sun, what happens is the head of the comet, which is nothing more than a big, dirty snowball, picks up radiation from the sun. It gets excited and it begins to outgas. And what happens is it throws out an amazing trail of material behind it. And this is what we're seeing, this ion trail that makes its tail. It's also shedding all sorts of debris. It creates a column of material in its orbit that spreads out literally millions of miles. And then as the Earth passes through this debris field, the particles are pulled into the Earth's atmosphere by our gravity. They're accelerated to extremely high speeds and they burn up from the friction in the atmosphere. Most of the material that comes in with a meteor shower varies in size from like a grain of sand to maybe up to the size of a pebble. This is a more recent photograph of the comet Swift-Tuttle. This was made in 1992 when the comet was close to the Earth. It swung around near the Earth. This comet has a relatively short period. It's only 133 years, so it won't be back until like 2126. So I guess I'm just going to have to miss it the next time around. Okay. Now this is an image showing the path of Swift-Tuttle as it comes close to the Earth, and then it'll swing back out way into the outer portion of our solar system. And of course, here is a representation of that debris field it leaves behind. Now, we don't have to worry about hitting this comet. These debris fields are huge. And when I say huge, I mean tens of millions of miles across. We entered the debris field of Comet Swift-Tuttle in the middle of last month. We will be in that debris field until September 1. And Earth moves at 67,000 miles per hour in its orbit around the sun, or 1.6 million miles a day. So that's a lot of area that it covers. So we don't have to exactly intersect the orbit of the comet. We just have to plow through some of the debris it leaves behind. Okay. Now, obviously, the Perseids are not the only meteor shower out there. This is a list of major meteor showers. This is the list and these links down here that you will be sent after this lecture. It will come in with the notice of the link to the recording of this talk. Now, there's all sorts of information here in the chart, but the important thing is this. If we go down to the Perseids here, we see this is the activity period. The maximum occurs August 12. This is all information about where it is and how fast it is, etc. The really important number is this one. If you look at this chart, This is noted as ZHR. This is the zenith hourly rate. If you lie back on a clear night and look straight up at the maximum of the meteor shower, you will see approximately 100 meteors per hour. Now that's over and above what the normal background count of meteors is. On an average night, you're going to see 6 or 7 meteors an hour. So during a meteor shower, obviously you see many more. You'll notice.
We have a question about why are these meteor showers so predictable? I mean, how can you pinpoint years in advance, you know, the night or the nights that we're going to be going through this, the densest part of the meteor shower?
That's because we go through this debris field at the same time every single year, because the orbit of the comet is fixed and where we intersect that debris field is the same. So we know we're going to be in the maximum of the debris field on the night of August 12th. And that's the same for all of these other meteor showers. If you'll notice here the dates. And the next one after the Perseids is the Leonids in October. These are the, did that answer the question? I assume that did. I can go back here and you see, here's the orbit of the Earth going around the sun, and this is the orbit of the comet that makes the Perseids, and they intersect. We run into the debris field, the same place in our orbit, the same time of year every year.
So the pathway of the, if you could go back to that previous
Certainly, right
slide.
back here.
So the orbit of Swift-Tuttle, is it a repeated orbit by the comet, or is it a kind of a one pass through? So the tail just, once it's passed through, the tail just stays there, or the debris just stays there, basically?
No, this is a periodic comet. It will come back. There are other comets that aren't. They'll sweep through once and they're gone. This one is a periodic comet, and every time it sweeps through, of course, it leaves more debris, which sort of refreshes this debris field that we're going to go through. After the passing of a comet, for example, in 1992, when Swift-Tuttle came by the last time, it left more material, and we had some of our showers were a bit richer. Okay.
Okay, thank you.
You're welcome. Okay. Now, you'll notice this is class 1 showers. These are the real bright ones. There are 9 of these. But there are other classes, class 2, they just don't have as many meteors per hour. Class 3 doesn't have many meteors at all, but they're variable. Sometimes there'll be a lot more. Class 4, well, it's really very dim. This class was discovered using cameras, okay? But if you add together all of these meteor showers, there are actually 94 showers a year, which means almost every night of the year we're passing through some sort of cometary debris.
One final question on that chart. It referred to a time. Is that like Greenwich Mean Time, or is that Mountain Time?
Oh, I think this is GMT. I think this is Greenwich, or the Universal Time.
Right. And do you offhand know what the, would we add or subtract for Mountain Time?
We are, let's see, we're at daylight savings, so I think we're 5 hours ahead. So 0400, it would be like, what would that be? Well, it could be like 10. That would be a rough. Yeah, it's 5 hours because we're on Mountain Daylight, so that would be 9 our local time. When we go back to standard time, it becomes 6 hours.
Okay,
yeah,
great.
That's the difference.
Thank you very much.
You're welcome. Now, where do these comets come from? And if you look at this really terrible poster of our solar system, because the scale is way off, we of course see the sun, Mercury, Venus, Earth and the moon, Mars, the asteroid belt, which was going to be a planet, but it got torn apart by the gravity from Jupiter. This is a giant planet. Saturn, Uranus, and Neptune. And then out beyond Neptune, in the region around Pluto, the minor planet out here, is a belt of material left over from the formation of our solar system. That belt is called the Kuiper belt, named after the astronomer who discovered it. And this is a donut-shaped ring that surrounds our outer solar system. This has hundreds of billions of objects in it, and it contains, in addition to big chunks of rock, it contains those dirty snowballs that become comets. And we see here an orbit for a comet. And what'll happen out here is this stuff moves around. Two of them will bump into each other and kick one of them toward the sun. The sun's gravity will grab it and it will orbit. And as it gets closer to the sun, the energy of the sun excites this dirty snowball and it forms the tail of the comet, sweeps around the sun and then goes back out into the Kuiper belt. The Kuiper belt is the source of the short period comets. That is, ones whose orbital period is about 200 years or less. So comet Swift-Tuttle is one of these short period comets because its orbit is only 133 years. Okay. Now, there are also long period comets. Those are ones with periods in excess of thousands, even hundreds of thousands of years. They come from a different part of our outer solar system known as the Oort cloud. And that's this spherical cloud of material here. You see, here's our sun, the inner solar system with the planets. Here's the Oort cloud. And then farther out is this sphere of material, which represents the limits of the ball of gas that condensed and formed our sun and planets. I love this too. They can't help themselves. Whenever they show anything like this, they have to throw comets in because comets are cool graphically, etc. I love that. Okay. Now, an example of a long period comet is comet Neowise, which we saw, which was visible to the naked eye last month. This is a photo I made of Neowise on July 18th. And you can see this marvelous fan of a tail. You see it forming a smaller second tail here. And if you look closely, you can see undulations in the tail. This is a long period comet. It won't be back for over 6,000, almost 7,000 years. So we know this one came from the Oort cloud. Okay. Now, this one will not leave a debris field that we pass through, so it will not create a meteor shower. The thing about long period comets, because they go past the sun so rarely, is they tend to be much more spectacular. Because every time a comet goes around the sun, it loses some material. The more often it goes around the sun, the more material it loses, and its tail isn't as big anymore. It isn't as flashy. Okay, but this particular comet certainly was flashy, and it was it's rare that we have a naked eye comet. So this was a wonderful sight, and I hope everybody got a chance to look at it.
Tim,
Now,
we have a couple of questions. The first question is, are there comets that totally surprise astronomers that just sort of come out of nowhere? And then the second question is, will you be talking about why there are two tails and why they look so different in comets?
Okay, yes, there are ones. Neowise surprised us. I mean, normally, again, you name comets after their discoverer. Well, Neowise isn't a person. It kind of sounds like, Dr. Neowise. He should be some arch villain in some movie or something. But no, it was an automatic camera system. And his initials are Neowise. I have no idea what they stand for. But it picked it up and people went, oh, look at that. But there are always people looking for comets, but occasionally we are surprised, like with this one, especially that it became so bright. As far as why this forms a second tail, we didn't really understand it until we literally flew a spacecraft through the tail of a comet. And we looked very closely at Halley's Comet at the head of the comet. And what we found is a very rough surface, and that as the sun excites it, sometimes all of a sudden there'll be a portion of the head that begins to spew out material for a short period of time that doesn't go into the tail. It'll shoot out like this and form a little second tail. This tail, by the way, disappeared as the comet moved away from the sun. Okay. Other questions? Any other questions about that?
There's nothing in the chat. I'll talk really slowly in case someone's madly typing in a fresh question.
Well, we can always go back.
Okay. Yep. Nothing yet.
Okay. Well, in order to study meteors, one of the things that we do is look up with cameras, because we can record over every night of the year and photograph comets. And it used to be that you had to be a real geek with a slide rule and a holster and a pocket protector to cobble together the equipment to do this. But nowadays, you can buy an automated camera. I think they're around $1,100. Plug it into your computer, plug it into a power source, turn it on, and it will automatically trigger when it detects a flash of a meteor, and it'll record it. And a lot of people do this because we not only want to know how many or what direction they're coming from, how fast, we can also look at the light generated by a meteor, and we can tell what it's made of. And most meteors have iron in them, so we know there's a lot of iron meteors. Now, a person in Idaho who has one of these cameras and is doing studies of that is a woman named Anna Morris, who lives in Glens Ferry. And she has one of these setups, and her work goes to the American Meteor Society here. And here's her system and the location. And of course, here she is on the map, and a real nice photograph of her. She was scheduled to speak to the Magic Valley Astronomical Society this summer, but all that got canceled because of the COVID-19, although we're hoping to get her as a Zoom presenter in the fall. Well, one of the reasons why we want to know about where these meteors are and what they're doing out there is because they do indeed pose a threat to Earth. Meteors come down all the time, and some of them do reach the surface of the Earth. And we know the Earth has been impacted quite a bit, and we know that for the simple reason You just have to look at the surface of the moon. All of these craters you see are impact craters from material striking the moon. Well, this material that was speeding through space didn't just strike the moon and spare the Earth. The Earth got blasted too. The reason we don't see it is because the Earth has tectonic plate movement and erosion due to our weather. Glaciers have moved over areas and scrubbed them clean. That doesn't happen on the moon, so we get an idea of how many impacts have really hit the Earth. Now, some of these past collisions with planet Earth have been devastating and have altered the history of our planet. The most famous of these occurred about 65 million years ago when a huge meteor smacked into an area near the Yucatan Peninsula. This was an object about 6 miles across that came into our atmosphere moving at 20 to 30,000 miles an hour. And when it hit the planet, it altered our atmosphere to the extent that we had a winter that lasted for years. And it wiped out the dinosaurs. And this altered the history of our planet, because what did survive this were the mammals, of which we are one. So the dinosaurs, I'm sure, looked up and, well, I'm sure like us, they're going to blame the media for all of this. Okay. But more recently, we have a beautiful meteor crater in Arizona. This is near Winslow, Arizona. This is the Barrington meteor crater. This was a large meteor that struck the Earth about 50,000 years ago. The crater itself, this is the visitor center and parking lot here. The crater itself is about 3/4 of a mile across and is over 500 feet deep. And over 50,000 years, a lot of the crater is filled in from erosion. So we know it was a lot deeper at one time. If you look here, you see the side of the crater is a straight line. This is because when the meteor impacted, its shock wave went out and hit a fault line in the rock strata and sheared it along that line. The force of this impact has been estimated at about 10 megatons, the equivalent of a 10 megaton thermonuclear explosion. It would have absolutely devastated anything for miles around. Obviously, something like this hit in a city today, it would be catastrophic. This is one of the reasons why we want to know where all this space rock is. And so we're doing quite a bit of study work to be sure that near-Earth asteroids are plotted. NASA is also conducting an experiment, is beginning to do that now, on shifting the orbit of an asteroid to see if the technique that they're going to try out will work, where they try to boost it into another orbit. They're doing this way on the other side of the solar system. So if something screws up, it doesn't move it into an orbit that would hit the Earth. Okay. This is another photograph of the Barrington crater. We're looking across that crater now. If you're ever down near Winslow, Arizona, go take a look. It's really a fascinating sight. It really is out in the middle of nowhere. Okay.
Do you know how big that meteorite was when it struck? Did it explode above ground like some of them do, or did it actually penetrate this actual surface? So is there really a meteorite down inside there?
They have excavated the meteor, what was left of it. It did strike the Earth. They estimate it was about 160 feet in diameter. The Harrod Center on College of Southern Idaho's campus upstairs near the observatory dome, they have a piece of that meteor. And it's hung on a chain, and you can actually go like pick it up. It's a small piece, but it is heavy because it's almost completely iron. So there was quite a bit of mass struck to make this crater. And down here you can see that little house there is where they set up at drilling facilities a long time ago to drill down and see if they couldn't find more pieces of it.
We have another question that's come in. I don't know if you're familiar with Sunset Crater, but someone was asking how big is this crater compared to Sunset Crater?
I don't know where, I'm not familiar with Sunset Crater. If somebody, if you could,
we might get more information in the chat here.
Okay.
Where is that Sunset Crater located?
Okay, I'm not familiar with it. I would have to look it up.
Okay.
Initially, when they saw this Barrington crater, they thought it was volcanic. And it's named after Barrington because he was the geologist that kept saying, nope, it's a meteor. It's a meteor. And he was able to prove it. Okay, I'll be happy to field that question later if somebody, as I say, I don't know where it is, but I will look that up.
Great, thank you.
Okay, now, in addition to impacts like this, meteors have been part of human culture since our earliest times. The oldest continuous culture on the surface of the earth is the Aboriginal culture in Australia. And this flaming meteor, and some of them do, as they come in, they throw off material, and you get these wonderful feathery streaks coming off the trail of the meteor. Meteors, as they enter, will heat up to about 7,200 degrees Fahrenheit. So they really are glowing, and they will sometimes eject material like this. Well, when the Aborigines saw this, in their mythology, which goes back, their recorded history goes back 40,000 years. And in that history, they believed that evil spirits rode these fiery meteors in, these feathery ones, and they would land on the earth, depicted here as this evil spirit with long claws here. It's reaching in and stealing the souls of people, in particular children. You see people here dead and a child down, and here's this horrible spirit about to get this other child. And what the Aborigines would do is they would light their spears and throw them up in the air to chase away the evil spirit. And obviously it worked. This is, by the way, is a bark painting. This bark painting is about 100 years old, but it's based on mythologies that are thousands of years old. Now, more in the Western culture, in the oldest temple complex in the world that is here in southern Turkey, this temple was built 13,000 years ago. And on the temple walls, on some of the support columns, are engraved representations of the constellations and a depiction of a huge meteor fall. These are some of the support columns. You can see part of one of the engravings here. Now, this meteor fall struck 13,000 years ago in Northern Europe, but the fall was visible from Turkey.
Tim, your image.
This is one of the stone columns that has the depiction of various patterns of stars. This one.
Tim, your image did not move through and to the next slide, and your image has frozen. Hello? Hello? Hi, everybody. I think what Tim's going to do is go out and come back in. So sorry. Technology's great until it doesn't work. Keep an eye out for him. Does anybody know where that sunset crater is? Have you heard of it before? Tim, you're muted.
Okay, I have no idea what happened. Suddenly, I just went away.
Yep. Your slide didn't, your slides didn't move through and you froze at the same time, so.
Okay, well, let's get back to it. It was a meteor. We're going to blame a meteor. Okay.
Some debris.
Right. Okay. Can you see this slide now?
Yes.
Okay. Well,
is that the one after the columns? We saw the map of Turkey, but then we didn't see the slide after that.
Oh, okay. Well, then you.
Right.
Okay,
So
here's the map of Turkey.
Okay, we saw that one. Yes.
Okay. All right. So I'm just going to pick up the talk from here.
Perfect.
Okay. This is ancient temple complex. It is the oldest temple complex in the world. It's 13,000 years old. And in that temple, they have a depiction of a huge meteor fall that occurred 13,000 years ago. That meteor fall struck Northern Europe. Now, in the temple complex, we can see engravings here on the columns, the support columns. And on one of these is that depiction. I could not find a photo of it. But here is one of a column that shows different constellations. And we see here what's obviously a scorpion and representing the constellation Scorpius, which of course you can see in the southern sky in the evening now. What's important about this particular meteor fall is it was so massive that it literally created a mini ice age. And it led to the demise of a large number of the megafauna that lived in Northern Europe. When we talk about megafauna, we tend to think of the woolly mammoth. But let's bear in mind, there were some pretty big predators there as well. We're talking about the saber-toothed cat, dire wolves, which were like normal wolves on steroids, the short-faced bear, and other predators. With these thinned out, if not completely eliminated, it made it far easier for humans to migrate north and settle in Northern Europe. So this meteor fall had direct effect on the settling of Europe. Well, other things have happened too. Now, if we look at this little comet, this is Tempel-Tuttle, okay, and there's not much of this comet left. And the reason is it's a very short period comet. It goes around the sun once every 3.3 years. So it's been around a lot. It's lost a lot of its material and there's not much left. This particular comet is responsible for the Leonid meteor shower. And that's not a real strong shower. There's just not much debris left in this debris field. But occasionally, it will be a massive shower. In fact, it And this is when instead of
Tim, we can't hear you again. We're on the Temple Tuttle slide. Can you hear me? I can't hear you. Tim, can you hear me? Shoot. What is going on with that? I apologize, everyone. One of our first talks, we had a power outage because the top of a power pole broke off. You know, we've had all kinds of funny things that's happened. Here he comes. Okay.
I'm back.
It's the strangest thing.
I have no idea what happened. I just got a message that suddenly I lost the link. Okay, I'll pretend I know what I'm doing. Okay, let me back up. I think this was the last slide that everybody saw.
Yes, correct.
Okay.
And it had gone around the sun many times and there wasn't much left.
Right, and it's responsible for the Leonid meteor shower, which is not a very strong shower, but occasionally there'll be an incredible outburst of activity to where it won't even be a meteor shower anymore. It's what we call a meteor storm, when instead of 50, 60, maybe 100 meteors an hour, we'll see thousands of meteors an hour. This is a very rare event, and associated with this particular shower, the Leonids, in 1833, they had an incredible shower. And this shower was seen, of course, globally. People took it as a sign from revelations in the Bible, it's the end of the world. And people were throwing themselves off bridges. They were, of course, there were religious services around the world. It was really quite an event. This is another depiction of it. But fortunately, in 1833, astronomy was enough advanced that astronomers said, look, we know this is pretty remarkable, but it's normal. We know what causes this. And they were able to settle that. But this does happen rarely. And if you ever are out in one of these, it is quite remarkable. I've never seen one. Now, this is for the Leonid meteor shower. And in the late 1990s, we got a rather unique view of that meteor shower. This is the view of the meteor shower from space, actually looking down on a meteor shower as these meteors plunge into our atmosphere. I just think that's really a cool image. But there have been other impacts. And one of the more recent and one of the largest occurred in 1908 in an area of Siberia called Tunguska. What happened here is that a very large meteor slammed into our atmosphere and burst at an altitude of about 4 miles. Its explosive power was equal to that of a 30 megaton nuclear explosive. It flattened 800 square miles of forest. Here's another photo of that if you look at this tree right here, you can see where the root ball is. By following the fall of the trees backward, you could find where the center of the event was. Of course, it was also easy to see because to this day, that area is scrubbed blank. Now, this is an incredible event. And it did occur in 1908. We have eyewitness accounts. This is an eyewitness account of the Tunguska event. At breakfast time, I was sitting by the house at Vananara Trading Post. That's about 40 miles south of the explosion. I suddenly saw that directly to the north, over Tunguska Road, the sky split into two and fire appeared high and wide over the forest. The split in the sky grew larger. The entire northern side was covered with fire. At that moment, I became so hot I couldn't bear it, as if my shirt was on fire. From the northern side, where the fire was, came strong heat. I wanted to tear off my shirt and throw it down. But then the sky shut closed and a strong thump sounded. I was thrown several meters. I lost my senses for a moment. But then my wife came out and led me to the house. After that, much noise came, as if rocks were falling or cannons were firing. The earth shook. And when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, a hot wind raced between the houses, like from cannons, which left traces on the ground like pathways. It damaged some crops. Later, we saw that many windows were shattered, and in the barn, part of the iron lock had snapped. This event, had this rock come in at a slightly different angle, this would have happened over Moscow or Paris or London. Millions would have been killed. Immediately, the Russian science institutes began to send people out, but it was a couple of years before they were able to get a real expedition out here. Now, we know from samples that they took, plus modern studies of what's left of these tree trunks, we have found dirt and grime embedded in them, and with tests, we know it was extraterrestrial origin. So we know that it blew up and threw this material all over this area. And of course, yeah, go ahead, please.
You may be going to answer this. What makes some comet or some meteorites explode above the air like this one, and some others, like the one in Arizona, actually, strike the surface of the earth?
Well, the one in Arizona was almost solid iron, so it wouldn't. But they believe for a while this was actually a comet, because they said it had to be porous to explode rather than hit. But from the studies, they said, no, it was a meteor, it was an asteroid itself, but it was just real spongy. And so rather than having enough solid mass to reach the surface, it heated to a point where the inside got so hot it blew up. Okay, so it depends on how it's constructed as to whether it's going to blow up from the heat of entering the atmosphere or whether it'll make it to the surface. Okay. Well, there have been other incidences where meteors have caused damage. In 2013, a meteor streaked the early morning sky over an industrial city in Russia and exploded. The shock wave shattered glass, caused all sorts of structural damage to buildings, and put over 200 people in the hospital. This was very well recorded because of all the surveillance videos and stuff that were going on. In fact, there's a great video of this from the front of, I believe it was a police car that had its video going. Okay. And here's another meteor. This was early this year, January 21st. This one in England reached the ground and struck. And these meteors don't always miss things. For example, in 1928, a meteor came down, pierced a Model T Ford, went through the back seat, and dented the muffler. There's the meteor in the inset to the left. Fortunately, the car was parked and nobody was in it. And they retrieved the meteor from where it was buried in the street. I can't even imagine how you'd file insurance on that. You know, that would be something. In 1954, this poor woman, Ann Hodges, was actually struck by a meteor. She was lying on her couch in a small town in Alabama when the meteor came through the roof, through the attic, down, grazed her side, went through the floor and embedded itself in the basement. Interviews with her later said she never recovered from the shock. And they kind of attribute it to her early death. She was in her 50s when she passed away. Now, this particular meteorite, the owner of the house got custody of the meteorite and sold it for $400. Okay, I mention that because in 1992, this guy goes out to get in his car to go to work in Peekskill, New York, and this is what's left of his car. And he realizes nobody's hit it because the bumper isn't dented. And he looks down, and in his driveway, he finds this meteor. Now, he was more of an entrepreneur than poor Ms. Hodges. And he took his car around and had it as a show. And you could come see the meteorite for a fee. He ended up selling his car and the meteorite for a total of $400,000, okay, which I thought was quite quite good of him. Now, a lot of meteor material, most of it, in fact, reaches the Earth not in solid form like this, in big chunks, but in the form of dust. Actually, it is a powder. In outer space, the action of this debris field, they grind into each other and they slowly grind itself down into this fine dust. And this will filter down onto the surface of the Earth without burning up in the atmosphere. You can see this dust on clear nights. After the sun has gone down, just as the stars come out, you can see this tail coming up. This is called the zodiacal light. And this is the sun that's below the horizon shining up and illuminating the dust that's near the Earth. The ancient Arabs called this wolf's tail. You see a similar phenomenon early in the morning. Okay. Now, if you're in a really clear area at midnight when you look up, or when the sun is exactly 180 degrees away from the horizon, you might be able to catch a glimpse of a glowing patch in the sky, not associated with the Milky Way. This is called the Gleckenshine or the counterglow, and this is the sun reflecting off distant swarms of meteors and dust. Now, this cosmic dust filters down on the Earth every single day. In fact, they recently have been able to determine that this dust, which looks like this under a microscope, comes down at the rate of almost 100 tons a day, filters to the Earth. Most of it, of course, will fall in the ocean because of the surface area of the oceans. It's such a regular phenomenon that certain plankton use this as a food source. Now, if you look at this, A lot of this are like grains of various, silicates, etc. But you also see these little black balls here. These little spheroids are of iron. And there was a scientist who looked at this and he said, you know, if all this is raining down all the time, the largest area I can think of that would be collecting this regularly would be the roofs of buildings. So he got a ladder, climbed up to his gutter, scooped up a big handful of this, the stuff you have to clean out of your gutter every year, put it into a bucket, mixed it with water, took a magnet, covered the magnet in some plastic wrap, stuck it in the bucket of water, swirled it around, and when he pulled it out, lo and behold, there were all these little black dots on it. And when he looked at it through a microscope, there they were, these iron spheroids. This is another image showing these iron spheroids. This is a sample coming from Comet Wild that was brought back by one of our spacecraft. And this is a sample of the interplanetary dust that we found on the planet. And we can see, they're identical. Well, I thought, I'll try this. I went out, I happened to be in my shop, so I had on my apron and my safety glasses, and I grabbed a little mixing bucket and went out to where the snow was melting and formed this big puddle. And I scooped up a whole bunch of this muddy water. About this time, a neighbor drives by. He stops, rolls down his window and said, what are you doing? And I told him. And as he rolled up the window and sort of backed away from it, he said, you tell me how that works out. And how it worked out was simply, I tried it, and what I got on the plastic covering the magnet was a whole bunch of little black dust. And when I looked at it through a microscope, there they were, these tiny spheroids of iron from outer space. Now, I'm not going to say this is going to make cleaning out your gutters a pleasant chore, but it gives you something else to think about.
So, Tim, why are those iron particles so spheroid?
Evidently, that's how they form, how they end up grinding themselves down. I honestly don't know.
Yeah, because some of them are perfectly round, and that just seems to be the way they want to be.
Yeah, absolutely. Well, at this point, I was going to talk about, of course, and conclude the lecture with all sorts of stuff that comets gave to the Earth besides just these wonderful showers. But then on a listserv, I got this. The extraterrestrial source was a meteor. What they found now is a complete protein in a meteor. Now, organic materials have been found in meteors for quite a while. Amino acids have been found in meteors, but this is the first time they've found a completed protein. And this specific protein has the ability to split water into hydrogen and oxygen and release energy. In other words, this protein has a food source, and this is very close to being life. A lot of theories about how life was brought to this planet revolve around meteors literally bringing it to this planet. So when you do go out to observe the Perseids and you look up and you see this wonderful display, think about all the other things this is. This is debris from a comet that's leftover material from the creation of our solar system, and that these meteors bring to Earth so many different things. So this gives you something else to think about when you're enjoying this wonderful firework display. Okay. Other questions?
Yeah. Just, is there anything special? A few questions about the Perseids in
Of
particular.
course.
Is there anything special to talk about regarding the Perseids? Where would a person look, and why in some of these pictures does it look like the meteors are all coming from the same direction?
Okay. The reason we name this meteor shower the Perseids is because when the Earth collides with a debris field, it collides in an area that happens, from our point of view, to be in the constellation Perseus. I'm going to go back to one of my first slides where those streaks are so I can talk about it.
Okay.
All right. Okay, in this image, they all appear to be coming from the direction of the constellation Perseus. And that's because we're hitting the debris field there. Okay. Now, if you'll notice, and Kristen pointed this out before we started talking, look how this one isn't following that path. This one isn't a Perseid, it's a sporadic. That is, it's one of, it comes from a different source than these other meteors, okay? And this is possibly one here as well. But to observe this, lie back and look up. What I would do is I climb up on the hood of my truck and I lean back, I lay out a sleeping bag and I lean back on the windscreen like it's a Chase Lounge and look up. That's the best way to see them. And they will appear all over the sky, but if you track their trails back, the Perseids will all appear to come from the same area of space, which is in the constellation Perseus. Okay. This is an easy target for photography too. Put your camera on a tripod, open up the aperture all the way, put it on bulb, open up the shutter and wait for a couple of minutes, close it and keep repeating that. And wide angle lenses are great and you can get meteor trails that way. The stars will streak because of course the Earth is revolving, but you'll catch these trails interspersed with that are the meteors.
So I've heard it when you were talking about we're passing through the meteor shower or through the tail. I've heard it described as like you being in a car driving through a massive bugs, and they all seem like as they're coming towards you, they look like they're all coming from the same direction, but they could actually be going to the left or whatever. But from our perspective, it looks like they're coming towards us.
Exactly, and that's a very good analogy. I'll use that later, I'm sure. Yeah, that's exactly what happens. There's this material, and we're moving through it and happen to impact it in that direction. The other meteor showers are named for the constellations that the meteors appear to track from. The Leonids, obviously, the constellation Leo. The Orionids, the constellation Orion. Geminids, which are a great meteor shower. The only problem with it is it's in December and it's cold. That's the wonderful thing about the Perseids. It's a great meteor shower and the weather is mild. You can actually go out at night without having to bundle up. Okay.
Yeah, and for those of you who don't know where the constellation Perseus is, it's to the northeast. So northeast.
Yes.
Mm-hmm. Let's see, and a question, will hills obstruct views of the showers? What is the best time to view? Okay,
absolutely the best time to view would be early morning on the 12th, before the moon rises, because we are going to have a waning gibbous moon. It rises around 1 in the morning.
So before 1 in the morning or after 1 in the morning?
It will rise after 1 in the morning.
So we should get there at midnight, kind of?
Yes.
11 o'clock at night or midnight?
Yeah, and
okay.
But, you know, the couple of days before and a couple of days after the peak, you're still going to see them because we're still in that debris cloud. If you're down in a canyon, like let's say I live here in Bellevue, if I went up Slaughterhouse or Muldoon, those canyon walls would obstruct some of the, certainly some of the meteors. But if you get out to, say, the Croy Creek Trailhead out there, west of Haley, that's a real good place to observe. Just kick back in a lawn chair and look up, and you'll see them. They'll be all over the sky. I think the moon on the 12th, yeah, it rises around 1 in the morning. And that just, what that does is it lightens the sky, and so the dimmer meteors won't be as visible. The bright ones will certainly still be obvious.
And if you're Bellevue folks, I know I had a wonderful view of Comet Neowise by going down into the Bellevue Triangle. Some of those country roads down there, or Glendale Road, are it's pretty dark down there. So, Tim, here's a detailed question.
Okay.
Someone says, I am reading that the better direction to view a meteor shower is between 30 degrees and 150 degrees away from the radiant in order to see meteors from the side. Could you explain this? And I'm happy to read that again.
Okay, I know what they're talking about.
Okay.
I hadn't heard it expressed in specific degrees, but if I look at the radiant point that is in the constellation Perseus, if I'm facing it, I'm going to miss a lot of meteors that are going to be occurring all over the sky from in different areas. If I turn myself away from it slightly and look up, I'm going to see more as they streak by. And that's basically what they're talking about. I hadn't heard that about 30 to 150 degrees, but that does make some sense. If instead of facing them on, let's say I turn to my right about 90 degrees and look up, yeah, I would see more.
Does that help answer your question? Yes, thank you.
Okay, you're welcome.
Yeah.
Actually, I'm gonna set up a camera. I'm gonna have it on a tracking mount and try to make a photo like what you're looking at right now, where you make several exposures and you catch a bunch of meteors and then you put them all together in one file. And that's the direction I'm going to be looking. I mean, I'll be looking away from the radiant point. As in this photograph you're looking at, I'd love to get this portion of the Milky Way near the Sagittarius star cloud here. Okay. All right, other questions?
Not quite yet. Somebody did make a note that when we were talking about Sunset Crater earlier,
Yes.
said Sunset Crater is actually a cinder cone that is also in Arizona. It must be a famous larger cinder cone.
Okay, if it is a cinder cone, then it is volcanic origin and not a meteor. Mm-hmm. But as far as size goes, I don't know how big it is. Okay. That's another good place. Craters of the moon would be a great place to observe a meteor shower. If you get to the caves parking lot, if anybody's familiar with Craters of the Moon, that's a great parking lot, and it's got some good foreground stuff for making astrophotos. It's got some contorted trees and lava formations.
So for all you budding astrophotographers, there you go. So
yeah.
I don't have any other questions that are in the chat at this point, Tim. So I'm going to draw us to a conclusion. I want to thank you so much for these fascinating talks that you've given. All 4 of them have been wonderful. really exceptional. So thank you very much for your time and your expertise.